Hello everyone. In this video, we are going to cover the last topic of our chapter Euclidean geometry, and in this we will cover the equivalent version of fifth postulates. Okay, we have done the five postulates of Euclid's and the last one is equivalent to some another, so we will do this one. So if we start our video, then the equivalent exam is also known as Playfair's exam. Okay, this one is not given in the NCERT, but you can remember this thing. It will be more beneficial. Its name is Playfair exam. So it's most common or equivalent to the fifth one. It's written there, throw a given point. Okay, not on a line, any point. Exactly one parallel line can be drawn to the given line. Okay, which means suppose we have any line, this one, and any another point which is not on the line. Suppose this line is A, this is and AB, and this point is P. So this Playfair's exam says that from this point P, we can only draw one line which is parallel to AB. Okay, like this. We cannot draw any more lines instead of this one. Only one is possible. Okay. Suppose in a case we can draw parallel lines from this P. So suppose it will look like that. We think it's parallel, but if we increase this, then it will intersect. Okay, so it's not possible according to this Playfair's exam. So after that, we also have a theorem in which it is written that two distinct lines cannot have more than one point in common. Okay, two distinct line means two different. Okay, I am trying to say using this word that we have two different lines. So another example, suppose two different lines. So it says that the only common point between these two lines should be unique. Okay, and it's only one. You can highlight this one. Okay, so before going to proof, let me explain you another case. Okay, suppose these lines are L and M. Suppose we have another line PQ and they are parallel. Okay, so this one is P and this one is Q. So if I say P is parallel to Q, then they have no common points. And it's okay. There is no problem in this one because in the definition it's written there, they cannot have more than one common point, but they can have zero, which is less than one. Okay, so that's why it's okay. Now I am defining the proof for this case where they intersect. So it's written there, here we have two lines L and M. This one is L, this one is M. We need to prove that they have only one point in common, okay, which is this point. We have to show that there is only one and unique point. So for the time being, let us suppose that two lines intersect in 2 points, say P and Q. Okay, so it's this thing like the two lines P and Q, that there are 2 points P and something another like Q. They intersect at 2 points P and Q. The lines are L and M. Okay, I am defining all the points geometrically so that it will be more easy to you to understand. So it's written there, you have two lines passing through two distinct points P and Q. Yes. Now we can say L and M both passes through P and Q. Okay, now let's recall some postulates and exams which we have done. Then you will find the answer. It is possible or not. And it's written there. But this assumption clashes with the exam that only one line can pass through two distinct points. Okay, we have done this. Only one line can pass through two distinct points. So our assumption is wrong that there are 2 points P and Q. So there is only one point P which is the common point, and we can say our assumption is wrong. So we can directly say that only one point is in common with these two lines which are intersecting L and M. Okay, that's all for this proof. Now I have some questions which will revise all the concepts which we have done in this chapter. So first one is that state whether the following statements are true or false, and you have to justify your answer. So first one, only one line can pass through two distinct points. So its answer is true. Okay, because if we have any point and another point there, so only one line is possible between that. If we can draw any other line, suppose starting from there and okay, look like that, and if it reach to same point, then they overlap each other, and if it will move away, then they are different. Okay, so that's the point. So first one is true. Now two lines cannot have more than one point in common. Yes, it's also true. And for this justification, we have done this proof. You can refer to this one. Okay, I have given the very great example. Now the second one, how many lines can pass through one point? So from one point, infinite lines can pass. Let me explain. This is the point. So I can draw this line. I can draw this line. I can draw this line, this one, and this. So in such a way, we can draw many lines which can move from the one point. Now from two given points, only single or one line can pass. Suppose this is the line and the two endpoints are this, so only one line is possible. Okay, and our last question, which is question number 3, is that give an example of Euclid's common notion 5, and common notion 5 or exam is that the whole is greater than the part. So we have done the example of rectangle in the previous video. So in this one, I will give some mathematical example. Okay, suppose we have some collection of points or numbers which include like 1, 2, 3, 4, 5. Okay, this is collection of 5 points or 5 numbers, and if I say b is equal to only 2, so can you tell me which has more numbers, a or b? So we can say a has more numbers than b. A has 5 numbers, but b has only one number, which is 2. So this is the example of Euclid's common notion 5, which is the whole is greater than the part. So now after this video, we have covered all the topics in this chapter, and I hope we have done everything is clear to you. And still, if you got any doubt, then you are free to ask me using my Urban Pro profile. So thanks to you for attending this video. Bye.